Now we have the independence practice, and this one is in a page, this one is in your page 20 in your instruction book. So we have independence practice that we're going to do, finding the square root, lesson 2, problem number 1 and number 2, then we're going to solve the other problems. So in this case I have solved a squared equals to 50 for all values of a. So let me type the equation here. So I'm going to write the equation. A squared is equals to 50. Remember, if you have a squared equals to whatever number, we're going to apply square root in both sides of the equation. Square root. Don't forget that one is positive and also negative, plus minus. What happens now? This square goes away with the radical, so you have that a is equals to, I'm going to write this one, plus minus square root of 50. Now you ask yourself, is 50 a perfect square? For example, 4 is a perfect square. Why? 2 times 2. You have a number that multiplied by itself will give you the perfect square, 4. 9 is a perfect square. 3 times 3. Now, 50. Is 50 a perfect square? What is the closest number? So I'm thinking of 7. 7 times 7 is equals to 49. So if I multiply 8 times 8 is equals to 64. 50 is between these two numbers. That means it's a decimal number. So 50 is not a perfect square. So I'm going to erase. So now I'm ready to give my solution. What is the solution? Is C. Why C? Because we need to give all values of A. Not only the positives, not only the negatives, all values of A. So C is the right answer. 2. What is a perfect square? You have A, B, C, D. Okay, so what we are going to do, A. You have A. Do you have a number that multiply by each other will give you A? So I'm thinking, for example, here, 2 times 2 equals 4. What is the next number? 3 times 3 equals 9. Nope. A is not a perfect square because we jump from 2 to 3 and we have 4 and 9. Now 18. Is 18 a perfect square? So I start with trial and error. So I have 3 times 3 equals 2. 9. This one. 4 times 4 equals to 16. Is close. What is the next one? 5 times 5 equals to 25. 18 is not here. So 18 is not a perfect square. What is the next number? Let me erase here. So the next number in this case, we have 100, 200. And if you look at your table, this we said no. So I have 225. So remember you have 10 times 10 is equals to 100. Then we have 11 times 11 equals to 121. What is the next number that we have there? Is 12 times 12 equals to 144. Then we have 13 times 13, which is 169. Then we have 14 times 14, and then we're going to have 15 times 15. So 169, then we have 196. And this one is 225. So is 200 in these perfect squares? No, so 200 is gone. It's not the solution, but I found out that 15 times 15 is equal to 225. So 225 is the perfect square. See, using your table, we figure out the solution. So let me erase so we can move to the next problem. Now we move to page, still on page 20. It's asking, the fractions below are possible values of x in the given equations. Write the correct fraction inside the box for each equation. So I'm going to start with A. So you have x squared is equals to 4 over 9. As you can see, all the solutions are positive. So we are going to calculate only the positive side of the square root. So what we are going to do, square root, only the positive. So these two goes away. And what I do, so remember you have a property, and I think you learned it the years before. If you have square root of a over b is equals to the square root of a over the square root of b. It's a property of radicals, that you can split that fraction into two square roots so you can simplify. For example, you have x is equals to square root of 4 over the square root of 9. So x is equals to, where's the square root of 4? 4 is a perfect square. 2 times 2. So it's 2 over. 9 is another perfect square. So square root of 9 is 3. Because 3 times 3 equals 9 and 2 times 2 equals 4. So what is the solution of x squared equals to 4 over 9? 2 over 3. So I'm going to 2 over 3. Now look at this problem. Remember that we are finding the possible values of x. So what I'm going to do with this one? Okay, where's my eraser here? So when we calculate the square root, so you have a square root of x is equals to 3 over 2. Okay? So what we are going to do, when we calculate the square root of something, let me say x squared equals to whatever. I don't care about that side. When you calculate the square root, usually you have an x squared on one side, and we usually say this square goes away with the radical. So now with this step, we're going to do the opposite. I have the square root of x, so now what I'm going to do is elevate this one to the second power, but you're going to do it in both sides. Both sides. Okay. So what happens now? So I'm going to have these two cancels the radical, so you have that x is equals to, look at this 3 over 2. There is a property that says that you have a over b to the n power is equals to a to the n over b to the n. Properties of exponents, the lesson 1 that we did. So we have 3 to the second power and 2 to the second power, following those properties of exponents that we saw in lesson 1. So what we are going to do now, 3 to the second power is 9, so x is equals to 9 over 2 to the second power is 4, and my solution is 9 over 4. So 9 over 4. This one goes away. C. I have x squared equals to 81 over 14, 64. Same situation. If you have x squared, you calculate the square root, positive, because they are only giving me positive numbers. And these 2 goes away, so x is equals to, 81 is a perfect square. What is the square root of 81? What is the square root of 81? Is 9 over square root of 64. What is the square root of 64? 8 times 8, so it's 8. So I have 9 over 8. I only have one left. D is the only solution, 81 over 64, which is the opposite of this one. So what we did now, look at this one. You have 9 over 8. I'm going to do it here. Square root of x equals to 9 over 8. And if you elevate this one to the second power, you do it on both sides. So it's the opposite of the square root. So these two goes away with the radical. So you have x equals to 9 to the second power, 8 to the second power. So x is equals to 9 times 9, 81. And 8 times 8 is 64. To 81 over 64, your solution. That's problem number 3. Okay, remember, if you have any question, let me know. Send me an email, Mark, or private message in Google Classroom. Let's move to the next problem. That's page 21. Page 21. Let me move this one. So I have, use the numbers shown to make the two equations true. Each number can be used only once. Write the number in the appropriate box for each equation. So you have 3, 6, 136, 1000, 1.7. So what we're going to do, okay, so I have square root of something equals to something. And the square root of something equals to something. So, which numbers do I have? 3, 6, 136, 1000, 1.7. I know 36 is a perfect square. 36 is a perfect square. So I can calculate the square root of 36. Equals to 6. 6 times 6, 36. Perfect square. Now here, you need to be careful. In my book, if I look at my book, I have this sign. This one is not equal. It looks like equal, but it's this symbol. And this one is approximately equal to. So it's an approximation. That means we are not going to have a perfect square. So what I'm thinking here is square root of 100 is not here. 1000 will not give you 100 or 6. 6 will not, we use 6 already. So we have 3. Okay? So I'm assuming, and I need to prove it, is 1.7. I'm assuming. I haven't proved it yet. So let me do it. 1 times 1 equals 1. 2 times 2 equals 4. So in this case, 1.7 is between those two values, and 3 is between 1 and 4. So this is the correct answer. Okay? So if we multiply 1.7 times 1.7, we will get something close to 3. Okay? So in this case, we're going to move to problem number 5. And I need you to go slow with this one because I have a bigger equation. This is an equation that I solved in Algebra 1. It's an Algebra 1 equation. So we need to go slow and find the exact value of x, then approximate the value of x to the nearest 10th. Approximate the value to the nearest 10th. What I'm going to do, solve the equation first. Remember the golden rule. Whatever happens in one side of the equation, it happens on the other side. For example, if I have a and b, a equals to b. If I add a number, I'm going to say c. If I add that number, I have to add it in the other side. That's the golden rule of equations. Whatever happens in one side, happens in the other side. Okay, so let's apply that rule. And I'm going to make this one equation bigger. So I have 2x squared minus 3 equals to 87. So the first step I'm going to do is cover my variable. So I cover my variable. Okay, so you have negative 3. In equation, we're going to move this negative 3 to the right side. I'm going to use the opposite of this number. So if you have negative 3, I'm going to use positive 3. So plus 3 plus 3. What happens now? Negative 3 plus 3 is equals to 0. So I just say cancels out. So you have 2x squared is equals to 87 plus 3 equals to 90. Now, what we're going to do, I have 2 is multiplying x. We need to leave x alone. So you cover your variable. What you have? 2. What is 2 doing? Is multiplying. So I'm going to divide both sides of the equation. Whatever happened in one side happens in the other one. So you cross out this number. 2 divided by 2 is 1. So you have that x squared is equals to 90 divided by 2 is 45. Now we have an equation that we know. Now we have an equation that we know. That equation is 45. X squared equals to 45. So we're going to square root plus minus square root, because they are asking me to find the exact value, then approximate the value. So we're going to use the plus minus, and in this case, this square goes away. So you have that x is equals to plus minus 45. I'm going 45. It looks 4 to the 5 power, but it's 45. Square root of 45. Okay, so I have the exact value of x. X equals to the square root of 45 plus or minus. What we're going to do now, we are going to find the approximate value of x. So you have 45. Okay? 45 is not a perfect square. So I need to find two numbers that get close to 45. For example, in this case, I'm going to have 6 times 6 is equals to 36. So I have 36. And then 7 times 7 is 49. So it's between these two. So this is 6 times 6 and 7 times 7. So my solution is between 6 and 7. Is between 6 and 7. So I'm going to put it here. 6 is less than the square root of 45. And is less than 7. Okay? So now we need to find a number that multiplying each other will give you something close to 45. And because this has been a long video, I'm going to have 6.7 times 6.7. And then I have 6.8 times 6.8. And those two you're going to get, if I use, in this case, multiplication, but I take 44.89. And the other one will be 46.24. 46.24. So in this case, we're going to have that x is approximately equal to, which one would you choose to get solution? Which one would you choose? I'm going to choose 6.7, and I'm going to have plus minus 6.7. So that's the approximation to the nearest 10. To the nearest 10, that means we only have one unit to the right side. Then you answer the question, x equals 2. I'm going to put here. Let me use a different color. X equals to plus minus the square root of 45, or x is approximately equals to plus minus 6.7. Remember in the classes that we've been doing this activity, we've been having 36, and we're going to have here 49, and we've been multiplying. This one is 6 times 6, 7 times 7, and then we do 6.1 times 6.1, 6.2 times 6.2, 6.3 times 6.3, until we get something close. In this case is 6.7 and 6.8. So that's problem number 5. So now Number 6 says, describe. So you're going to write something here. Describe how you could use inverse operations to solve the equation x squared equals to 4. So in this case, we saw some examples, and I know in this case, well, yeah, that's supposed to be a W. I know squaring and finding a square root are inverse operations. Okay, so for example, if we have x squared equals to, let me say, 4, we use the square root. So we square root, I'm only going to use the positive, okay, just for this example. So this square cancels the radical, so you have that x is equals to 2. Square root of 4 is equals to 2. Now, to do square root of x equals to 4, we need to eliminate that radical, so we are going to use the square. So we're going to square both sides of the equation. Remember, whatever happens in one side happens in the other one. So these two eliminates the radical, so x is equals to 4 to the second power. 4 times 4 equals to 16. So I know in this case that squaring and finding the square root are inverse operation. Okay? So in this case, to undo, the square root, in this case, I can square both sides of the equation. For example, if you have the square root of x equals to 4, so you square both sides of the equation. And this one goes away, so you have that x is equals to 16. And in this case, that's the last page of individual practice, and that's your solution. If you have any questions, as always, make sure you send me an email or type in the comment section, and I will see you next class. I hope you have a wonderful day. I will see you next week.